the idea is that you can now use computed fields when specifying join conditions for remote schema joins, remote schema relationships. And similarly, for a computed field in the GraphQL API, you can now use them in Boolean, in where clauses and order by expressions, and in permissions too, wherever you're allowed to use Boolean expressions. And you can use computed fields, for example, like in all of the filter and check expressions that you define. So with remote joins, the kind of use cases that this would cover is if on the source end, the data is in a slightly different format than what is expected by the remote, you can do this sort of like transformation. And at the same time, if the data is not readily available as a column, but you need to like extract it using some JSON from a JSON payload, or maybe you'll have to like compute it on the fly, then like these use cases are covered by this. So I'm going to quickly give you a demo. So I have a simple table called state, which stores a country code and the name. The country code is stored in lowercase here. And I have a remote, there's a public remote schema, which like gives you country detail with the country code, except it accepts in in uppercase. And if I define, so this is what I have. So I have, that should come later, right? So this is what I start with. So I have, I track the table state. I define a remote relationship using the country code that's already present in my database to this particular remote schema. And let me quickly apply this metadata. Okay, I haven't created that table. All right, so let me make this simple GraphQL query. You'll see that you can't get the data from the remote schema. I'm gonna create a computed field now. And in the computed field, the data is converted to uppercase. I'm gonna create this thing, and this is the new metadata. So where I have a computed field and I use the computed field in the remote schema definition. So now I'm gonna apply this again. And let me make the same query. You can now see that it fetches the data correctly. All right, let me switch to the next one. So you can now use computed fields in the GraphQL API, order by expressions, and the Boolean expressions. Obviously, you have a better API now. And at the same time, if you make any changes to your data model, given that a computed fields schema is as close to a column as possible, you can now, let's say, split a column into like 2 different columns and create a computed field which mimics the behavior of the older column. So that way your older clients still continue to function with the older API. So let me give you a quick demo. So I have now a sample database, and there's this particular table which has a couple of columns, except the total cost and the quantity of an item is stored. What I would like to see is a per item cost, and this particular computed field cost, that is a simple division expression. I'm going to create this, and I'm going to look at the metadata for this. Right, so just a simple configuration of the database, a table, and a computed field. I'm going to apply this. Okay, you can see that this particular query now uses cost per item, which is a computed field in the ordering, and it uses it also in the Boolean expressions. So if I make this query and if I click analyze, you can see that because it's an expression, Postgres has to do a sequential scan to fetch the data. We can, given that Postgres supports expression indexes, we should be able to like do better. So what I'm doing is creating an expression index on this particular table, and the expression being the exact same expression that I used in my computed field definition. I'm gonna create this index, let Postgres update its statistics. I'm gonna go back. So you can see that the cost is about 4,000 units. once again, it analyze, you can see that the cost has come down. So the SQL that we generate for these computed fields is simple enough that Postgres can see through that expression and use the expression index where possible. And the final one is permissions. The use cases here are like, obviously you can now specify a much broader range of conditions at GraphQL engine layer. And also if you have like complex permissions and you do not want to configure that for every table and like using relationships, you can just add a computed field and which abstracts out all of this complex condition checking and use that directly in your permissions. So let me again take you over a quick demo. So a simple table, except the information of the information that's required to enforce permission is stored in a JSON-B blob as follows. It has a user and an editor key. And I've created a computed field which extracts this user ID out of that JSON blob. Let me show you the metadata for this. So the metadata, so the computed field is called user. And I'm using the user column directly in the permissions. Let me quickly reset the database. And all right, okay, I haven't created this schema. All right, so I am gonna query this as a particular role user with user ID 1. I should be able to see the data, but if I query it as particular user 2, it should be empty because this computed field would extract the user information from resource owners and would apply the filter. All right, folks, that's pretty much it. If you have any questions, leave them in chat and I'll try my best to answer them.